So let's start thinking about our world here. So let's draw some pictures. So what we'd like to have is maybe initially 4 rooms. Okay? So we want to think about what is a room. So we want to start thinking about our objects here. So we already have our person, right? So right now a person has a name and has hit points. That's what a person is right now. So let's think about what a room is. A room is going to have a name, a description, and then a list of persons. List of persons that are in that room. Okay? Yeah, let's just leave it like that. All right, so list of persons that are in that room. It's also going to have a list of exits. So here's our rooms. This guy will have a name. It'll have a description. There might be 0 or more persons in that room. But then we also need to have a way of getting to the other rooms. So maybe there's an exit from this room that leads to this room. Maybe there's also an exit from this room. Oop, I thought I copied that. There we go. Maybe there's also an exit that leaves from this room into this room. So this room has 2 exits. Maybe one's to the east, one's to the south. All right, so exits might be stored inside of a dictionary where you have name value pairs. All right, so let's think about what's an exit. An exit has a name, it has a destination. Actually, it probably doesn't necessarily have to have a name. I'm going to leave it in there because the name is probably going to be part of the dictionary that we're going to have for our list of exits. All right, so it's going to have a name, it's going to have a destination, and that destination is going to be a room where it goes. So almost think about like a door. This door leads somewhere, okay? And when you take the door, you go to another room, okay? So that's what an exit might be. All right, so let's create a couple of these objects. So we have our person, and we're going to say our person's in pretty good shape right now. Now we're going to go ahead and we're going to create a class called exit. And a class exit is going to have a room that's going to be its destination. So init self destination. And we'll say self.destination is equal to destination. Okay, so we'll leave exit like that for right now, and then we'll kind of build them up as we go. And then we're going to have a class room def init. Going to have a name, a description. Those are the 2 pieces of information we're going to give the room. So self.name is equal to name. Self.description is equal to description. Self. Let's call this guy persons. List of persons. We'll start off as being the empty list. And then self.list of exits is going to start off as being the empty dictionary. The empty dictionary. Okay. So now some of the things that a room should be able to do is it should be able to add a person. Somebody should be able to enter the room, right? So we'll say def add person. And we'll say this or self dot list of persons dot append person. So that I'll put that person into this room. Def add exit. And this is going to be an exit that goes from this room into another room. Okay? So we're going to go ahead and this guy's going to take in self. It's going to have the name of the exit and then the exit itself. And then what we're going to do is we're going to set our list of exits, self.list of exits, at position name is going to be equal to the actual exit that leads to the other room. That'll add an exit to a room. All right, so let's just start with this and let's build a couple of things here. I'm going to take a lot of our logic out of here just to clean it up a little bit. Okay, so we'll go ahead and create room 1 is equal to room, and we'll call this guy room 1, a room. That's its description. Constructor for room takes in the name of the room and takes in a description. And then I'll go ahead and create our 3 other rooms. So this is 2, 3, 4. This is room 2, room 3, room 4. All right, and the description for all these guys is just a room. Okay, then we'll go ahead and let's create some exits. So I want an exit. So let's just create the exits for room 1 first. So if we're trying to follow our picture here, this is room 1. So we'll call this guy R1. We're going to have an exit that leads to room 2 and an exit that leads to room 3. All right, so we're going to have 2 exits in there. So R1, add exit. And we're going to say the name of this exit, because when we add an exit, we have to give it a name. If we look at our little picture here, this is kind of a door to the east. So we'll call that guy East. So we're going to add an exit named East. And it's going to be an exit that leads to, if we look at the constructor for exit, it takes in the destination room. So this is going to be R2. Similarly, I'll create an exit to the south that leads to R3. That make sense? All right, so I have 4 rooms. You can only actually get to, well, you can't get to any of them now, but they look like we have them connected up. So room 1 is connected up to room 2 and room 3 through an east and a south exit. Now we should go ahead and let's throw our person into the first room. So R1.add person. P1. All right, so that's going to be, now P1 is in that room. Now let's go and teach rooms how to display themselves. So I'll add another function here called display. And this would probably have the name of the room, followed by the description of the room. Then typically it would say who else is here, and then possible exits, something like that. So we'll say print self.name, print, maybe we'll say description, print self.description. All right, then we're going to print who else is here, print and now we want to loop through all the elements of our list of persons, showing each of their names. So for P in self.list of persons, print P dot person has a name, right? Yep, here's person, they have a name. So that'll print out the name of everybody else who's in this room, which right now is just going to be 1. And then we want to print out our list of, I'm going to kick this down a line just to separate this stuff a little bit. Then we want to print out possible exits. So we'll say for E in self.list of exits. Now, going through a dictionary, when we go through here, we're going to have, there's 2 different parts to traversing a dictionary. Let me show you this in the book. We go iterating over a dictionary. So the key in our dictionary is going to be our name that we put in there, like the east and the south. That's actually the part that we care about, the name of the exit right here. But we have actually 2 different pieces that we might be interested in. So here's a loop that loops through all the elements in a dictionary, but soda is going to be the key. Calories will be the value associated with that key, so we can get the 2 pieces. Right now, I just need to know the names of my exits, the east and the south part. Okay, so I only need the key part of this. So I actually could call this guy exit name if I want to be a little more explicit to exactly what it's doing. And then I'll say print exit name, like that. Okay. So that's what happens with our when a room displays itself. It'll print out the name of the room, then it'll print out the description, then it'll show everybody else who's here, then it'll show all the possible exits from this room. Okay, so if we come down here and I say r1.display, this should show me room 1, a room, who else is here? Mike. Possible exits, east and south. That's what we want this guy to show us. I didn't write display correctly. This guy needs to take in a self. Did I do that for my other ones? I did. So here's room 1. Description is a room. Who else is here? Mike. Possible exits, east and south. All right, so that seems to have our room going. Okay. Now, we can go ahead and hook up our other rooms. So let's finish building our map, if we will. So we have this little 4-room complex. Actually, why don't let's just forget about room 4. We'll just have it be able to move between 3 rooms just to keep this a little simpler, since we didn't even use room 4 for anything at this point. So room 2 is going to have an exit leading back to room 1. And that'll be to the west. Let's go ahead and create that. R2.addExit west, and you can call it whatever you want. Just directionally, it looks like it's to the west. And this guy is going to go to exit R1. All right, and then we're also going to have an exit, maybe from R2 to R3 to the southwest, something like that. Okay, and then R3 will have an exit going to the north. And that'll go back to R1. And that goes back to R1. All right, so maybe that's how our map looks. Maybe the only way to get to R2 is through R1. So I can go from R1 to R2 to R3 back to R1. Or I can go from R1 to R3 back to R1. But I can't get, the only way I can get to R2 is from R1. Something like that. You know, so I've built a map. And I've decided what leads where. Okay? So that's what we're doing all here by throwing those things together. But we've only put our person in the very first room. Okay? So now what we want to do is we're not going to actually have our room display itself on his own. Instead, we want our player to be able to kind of walk through this little maze, something like that. Okay? So that means that we have to have some sort of menu system for us to say, you know, be able to look around or take an exit, something like that. Okay? So we're going to go ahead and have a person also know what room they are currently in. And initially, they're not going to be in any room. So when a person first comes into existence, they are not going to be in any room. Okay? This is an important concept I'm about to point out here. Now, down here, when I add P1 to R1, when I add that person, this is my add person right here. So I'm setting list of persons. I'm appending to that list of persons the person that's being added. But I also need to let that person know what room they're currently in. So I'm going to say person dot cur room is equal to, I need to tell him about what room he's currently in. What room is he in? Well, you were good for a while until you put extra stuff after self. Self.description is the description of the room. The room itself is self. I am inside of an instance of room, correct? So if I'm inside of an instance of room, self is how that particular room refers to themselves. So from inside this room, if the room was told, here, take this person and add it to your list, the room is just going to say, person, you are in self. That's the room you're in, me. That make sense? So that's what I'm doing right here. I'm setting that person, the same person I just added to my list of persons for this room. I'm going to let him know that his current room is a pointer to me. Okay, that's the room he's in. All right, so now a person has been put in a room and knows what room they're in. So we're going to go ahead and we're going to create a little kind of a dungeon crawler type thing, something like this. So I'm going to create another class here. So we're going to create a class called Dungeon. And we're going to define an init for this guy. That'll take in self. And our dungeon can have a name if we want it to have a name. Okay. And then we're going to go ahead and we'll say self.name is equal to whatever name is passed in. And then we're going to go ahead and move a lot of this logic from out here into our dungeon. So we'll go ahead and this particular dungeon is going to have 3 rooms that get created. This particular dungeon is going to set up all these exits for those 3 rooms. Now, the dungeon is also going to have a self-starting room. And we'll set this equal to room 1 in there. So a dungeon will have a starting room where it begins. All right. So now we'll create a function here, def enter dungeon. And this will take in a person. And we'll say self.starting room dot add person. So this dungeon will add this person that's passed in to whatever their starting room is. And we set their starting room inside the constructor for it. All right, so now we'll go ahead and say we have the dungeon is equal to dungeon, and we'll call this scary dungeon. And then we'll say the dungeon dot enter dungeon P1. That make sense? And that will put the player in that first room. Okay? So now, when a player enters a room, we need that player to see information related to the room they just entered. So what we're going to do is we're going to be able to tell the player stuff. We need to have players be able to display things to their screen. Now, right now, this game is all going to be local. So their screen is our screen. We only have one screen. If we were thinking about this as like a network type game, and those are things that we would look at. We would look at some network programming type stuff in the next course, the 537 class, where we have multiple users connecting in over the internet and that kind of stuff. You might want to, if you had 5 users that were in this dungeon at the same time, you might want to say, I want to display this information to that user, this information to that user, this information to that user, because they're at different computers, possibly in different parts of the world. Well, right now, we're all at one computer sitting in front of this monitor, All right. So the idea is anything that gets printed to the screen gets printed to the player. So we get to see it. All right. So we'll go ahead and in our dungeon, after we've entered the dungeon, we're going to go ahead and create a infinite loop that's going to taking commands from the user. So we'll say while true, we're going to do some stuff. So we probably want to maybe initially show them the room that they're in. When we first throw them into the dungeon, we'll go ahead and say self.startingroom.display, just to give the player some orientation as to where they are. Okay? And then what we're going to do is we're going to give them a prompt, a place to type something. So we'll go ahead and we'll do print command, something like that. Give them a little space. And we'll have it all on one line. That way we can, when we press enter, it'll be coming right after the command thing. And then we'll read in command is equal to input. So we'll read something in from the user. All right. And then for right now, let's just print out whatever they read in. All right, this will happen forever. So we created the person, we created the dungeon, we added the person to the dungeon. What does that mean? We added the person to the starting room, we told the starting room to display itself, then we printed a command prompt out for the player and waited for their input. And right now it just mimics them, ticking them off probably, because they can just, whatever they type just spits back out to the screen. Enter dungeon, same problem. All right, so I'm sitting in room 1 with the description, a room. Who else is here? Mike. Possible exits east and south. So I might want to type in east to take the exit to the east. But right now it's just going to spit it right back to me and take me back to the command prompt. I wanted to respond to those messages, right? If I type in east, I want it to go to the east. If I type in south, I want it to go to the south. If I type in look, for example, I want it to effectively show me the same stuff that's already here. Look at the room I'm currently in. Okay? So, this loop right here, this is something that's relative to the player themselves, correct? So what might make sense is we might tell the player to start. So I'm going to steal a lot of that logic. We're going to go up to our person here. And we're going to give them another function. Maybe this is called, we'll just call it start for lack of a better anything else. So instead of starting room, we're going to say the cur room the player is in. We'll ask the room to display itself. While true, here's the ask for the command, read something in, spit it back out. All right, so now it's the player responding to inputs. That way later on, if we were to make this into a network game, players might live on different computers, and now we've compartmentalized the logic for their menu system in one place. All right, so then in our dungeon, after we've put the person into the room, we'll go ahead and say person.start, which will tell the person's menu system to start up. So person.start will come up here, call this function. The person will have the room they're currently in display itself, and then it'll ask them for a command. So So this should do the same thing it just did a second ago, but the means to end is a little bit different. So it's asking us for our command, we're typing in, but this is all happening from the perspective of the person now. Make sense? So we want to give a couple of commands here. One command we want to be able to type in is look. If we type look, it should show us the room we're currently in. That's what that command does. All right, so we're going to go ahead and we're going to create another function. This is inside of player. We'll call this guy process command. So you're starting to see the pattern here. With objects, we write a lot of small functions. That way we can, when a player needs to process a command, we just say process a command. And it goes and processes the command. So we're compartmentalizing our logic into little pieces here rather than having this giant, hard to follow chunk of code. All right, so process command, we'll take in whatever command we want to process, and we're going to find out which command they gave us. So right now we're only going to support one command, right? So we're going to say if command is equal to look, then we'll say self.curRoom.display. That's what we do when we look. Else, print command not found. Or you can put some question marks or whatever you want to do. Okay? So we read in a command. Well, actually, we don't even need to store it in command here. What we can do is we can just say self.process command, passing it whatever the user types. So our start here will print out the command prompt, read something in from the user, pass whatever they read into our process command, which is right here. Process command is going to look at that command. If it's equal to look, it's going to display the current room. Otherwise, it's going to spit out command not found. Okay, let's close this. All right, so I'm looking at the current room right now. If I type look again, it's going to show me that room again. So far, so good. I can look. If I type anything else, if I say, oh, I want to go to the east, it's going to say command not found. Make sense? Okay. Let's see, what else should we be able to do? So we should be able to say something as well. Maybe to talk to other people that are in the room. Something like that. Even though other people won't actually exist in the room, we just want to have some other commands that allow us to look at other things. Or I could maybe, let's just think about this. If I say, exits isn't going to make a lot of sense. Well, let's go ahead and give ourselves some monsters, probably. Should be monsters in our dungeon, right? Doesn't that make sense? Monsters to kill? Yeah. All right. You don't want monsters? You're afraid of monsters? Live in peace. All right. You have babies to take care of? That's better. All right, so this is a person that's controlled by us. So now we're going to create another class. Here we're going to go with monster. Init self takes in a name, and so we'll say self.name is equal to name. We'll give them some hit points. we'll also give them a cur room that starts off as none. All right, so we have this new class now called monster. Now, monsters are going to be able to generate and take damage as well as report whether or not they're dead. So they're very similar to persons, except they won't have like a command prompt that they can respond to. They're going to act autonomously. All right. And then what we're going to do is we're going to teach rooms to also have list of monsters. All right. So in our list of monsters, this guy is going to have, well, we can just have it be a list here like that, where we show the monster's name and then, yeah, this makes good enough sense. So we'll just say list of monsters. So then we need to be able to add a monster. Self list of monsters dot append monster. All right, and then when we display a room, maybe before we, so right now we're showing who else is here. So why don't we call this other players here. And then we'll say monsters for m in self.list of monsters, print m.name. All right, so we'll print out that monster's name. Okay, so then what we'll do is we'll go ahead and let's put a couple of monsters in that first room. Okay, so we need to go to our dungeon. So our dungeon's where we're building all our rooms and stuff. So now let's go ahead and let's build a couple of monsters. So we're going to have a M1 is equal to monster, and a monster takes in a name. So this is Jade, right? Then M2 is going to be another monster, and this one's probably going to be Promise. All right. So I'll have a couple of those guys, and then we'll say R1.add monster M1, R1.add monster M2. So now we should have a couple of monsters in that first room. So here's our monsters. Jade and Promise are in there. All right, I can still look. Now, I probably should also be able to quit, right? To exit out of the program. Okay, so let's go give it that ability for process command. Process command. So we'll do an elif. Command is equal to quit. Then we want to go ahead and exit out of our program here. So we're going to go ahead and say print goodbye. And then we need a way of getting out of this infinite loop here, or at the very least making our program immediately quit. Now, one thing we can do is rather than processing this command inside here, we can remove it from there. We can come in here and we can say command is equal to input. And then we can ask if command is equal to quit. And we'll print goodbye, and then we'll break out of that loop. Otherwise, we will process whatever command was read in. So we can treat quit as a special case, as that keeps us where our while loop is. So if we are told to quit, print out goodbye, break out of the most local loop, which is this while true loop. Otherwise, if we didn't get into this if statement, we'll go ahead and process the command. If you like using else instead, if that helps break it up for you a little bit better visually, that's equivalent. So otherwise, if it didn't say quit, we'll go ahead and process whatever command they gave. Okay. So let's go and test to make sure quit works. So I can look, I can quit, and that gets me out of there. Okay, so now there's really two things that we want to be able to do. We want to be able to, you get it 2 things in 2 weeks of homework? Well, it's really only 1 week thing, since the first thing I basically already gave you the code for the attack. I mean, you've seen me beat up Jade a bunch of times today. So that's going to be similar to the code you're going to have to write here. So we want to have commands for, sorry, not in there. If command is equal to attack, this guy should ask which monster to attack, read in the monster name, then create a fight between the player and the monster. Similar to what we did in class. Remember, both of these guys have hit points already. All right, just like they had in class. So still, they already know how to generate damage. They already know how to take damage. So you're going to do kind of the loopy thing for keep going until somebody dies. Make sense? All right. So that's one new command.
The monsters can fight back.
Yeah, they'll fight back automatically, just like we did in class. Nothing different. Else if. Now this one is a little bit we might even throw this inside the else. In fact, I'm going to have you throw it inside the else. Check to see if the command is one of the exits. If it is, take the exit. Now, what does it mean to take the exit? This means remove the player from the current room, add them to the destination of the exit, and make sure to update the player's per room. Something like that. All right, so the player should be able to walk around our little dungeon. So when you go into a room, they get added to the room, and then they could look around and see that they're in a different room. So if they type in, for example, they're in room 1 and they type east, it's going to remove them from room 1, put them into room 2, and then they'll be able to type in their commands again, like look or quit or attack, any of those things for room 2. Similarly, they can type in west to go back to room 1, or they can type in southwest to go to room 3. So they should be able to walk around our dungeon. That make sense? Okay. So that should get you some good practice with objects. So I'll give you all of this as a starting point. There's our dungeon starting point. All right, now let's talk about the final. So everybody in here has taken the midterm. They know what the test is going to look like. We will not have class next week because I will be out of town. So you have 2 weeks to work on this program, as well as prepare for the final. So what we'll do is when we come back, we'll spend the, let's say, the first hour of class solving this assignment. Okay? Then, it might not even be the first hour. It should go pretty quick. Probably the first half hour. But let's just say the first hour, just to give us room. The final exam will be very similar to the midterm that you just took. It'll be about the same length. It'll cover everything we covered up to the midterm. It'll also cover the stuff we talked about today. So there'll be questions on there related to classes. So you should have lots of practice over the next 2 weeks working with objects and that kind of stuff. All right. You can have the entirety of the rest of the class. So the 3 hours that we have left to take the exam. I'm designing it to take an hour, just like the first one. Okay? So for those of you who had some time constraint problems on this, that should not exist on the exam. I'm not going to design it to take 3 hours. It will be the same length as the exam you took last week. But you can take as long as you want on it, up to 3 hours, let's say. That sound reasonable? Yeah. Okay. So make sure you study the midterm I handed back to you. Because remember, I have the policy that if you do better on the final than you did in the midterm, I'll replace the midterm exam grade score with whatever you get in the final. So if you did crappy in the midterm, you can fix it. Okay? So you almost get a do-over. So the only thing new on the final will be the object stuff, which you're going to be practicing with this assignment. Now, some hints for this assignment. I've said them most out loud now, but as you go through the code, first, I would encourage you to walk through the code yourself and make sure you understand how it works. Because what I've given you here looks like a lot of code. So it can feel intimidating at first. But really, it's just a whole bunch of little tiny functions that do like 2 things, right? So you want to look through it and make sure that you understand why it does what it currently does. So that adding the new stuff to it won't be that big of a deal. I've even put comments in there where you should be adding new stuff. All right, but you'll have to figure out the logic for moving between rooms or attacking somebody in the room. That makes sense? All right, so you have 2 weeks to do the program. Exam will be same format as the last exam, but you'll have 3 hours plus or whatever to take it. Basically, nobody should have a time constraint issue with the exam. I will be around next week. I'll be out of town in Arkansas, but I'll have internet access and stuff like that. So if you have questions about the program or you want to clarify something for the exam, I'll be able to reply to Slack and things like that. So I'll be in communication. I just won't be here in Mequon. All right, questions, comments, concerns, bribes.
Can I ask?
Sure.
So you said the final exam is going to be quite similar to the midterm. So does that mean we need to review the theoretical things we covered about the historic languages and the decimal thing and the conversion, or does that mean we need to focus on the coding part of that course?
It will probably be similar to the midterm, but I think the answer you're looking for is it's probably going to focus more on the coding. So either more reading code. So for example, if you take the midterm, I would probably not ask the question about the loosely typed languages and replace that with either another programming question, maybe something with objects, or another question where I show you some code and ask you, what does this do? Something like that. But in general, it would be the same kind of layout. But if you're going to spend time studying, I would study more of the programming stuff. But I won't ask you the difficulty of the questions will be similar to what the difficulty of the programming questions was on the midterm. So if I give you stuff on objects, it'll be pretty simple little objects, like kind of like what we did with fractions. Fractions were not very difficult until we learned about the time complexity issue. But to add fractions together, that was like 4 lines of code, right? So I want you to be comfortable with objects from that perspective, but I'm not going to ask you to solve some very complex algorithm in a sit-down test. Make sense? So don't expect things to be more difficult than they were on the midterm from a logic perspective. But do make sure you add the objects and stuff we talked about today into your new repertoire of tools. All right, anything else? Okay, and like I said before, I was pleasantly surprised. The class as a whole did much better in the midterm than I did not expect it. So that's good. Now with that in mind, I know you guys are loving the programming stuff. I'd still strongly encourage many of you to take the 537 class. I think it will be good for several of you. Because honestly, several of you have shown some pretty good competence in programming, which is saying quite a bit given that this was shoved down your throat in 8 weeks. So that's not the best way to learn programming. So you might have kind of a knack for it. All right, I will see everybody 2 weeks from today. Sound good? All right.